Welcome to the Explainer. Today we're going to talk about a tool that is an absolute game changer for anyone in machine learning. It's called Data Version Control, or just DVC. So let's kick things off with a question. Have you ever tried to add a big dataset to your Git repo? You know the drill. You've got your code, your model, this huge data file. You go to commit it all, and boom, everything just grinds to a halt. Your repo gets massive, and trying to work with your team becomes a total nightmare. And listen, if you've run into this, you're not alone. It's not a bug, it's kind of how Git was designed. Git is absolutely brilliant for tracking changes in small text files, your source code. But when it comes to the huge data sets we're using in ML projects today, it was just never built for that. Even Git's own creator admits it. Okay, so this leads us right into the heart of the problem, the ML reproducibility challenge. Think about it for a second. If you can't properly version control your data, how on earth can you ever guarantee you can reproduce your own results down the line? And this really is the key, isn't it? An ML project isn't just about the code. It's this three-legged stool. You've got your code, your data, and your parameters. If you can't lock down the exact version of all three of those things together, well, you can't really guarantee you can reproduce your work. It's like trying to bake a cake, but not knowing which ingredients or oven temperature you used. Good luck getting the same cake twice. All right, so that brings us to the solution, introducing DVC, which people are calling Git for data. So how do we fix this massive problem without just tossing out a tool like Git that we all know and, mostly love? This is exactly where DVC steps in. Okay, so what is DVC? Well, at its core, it's a free, open-source tool. And the idea behind it is just brilliantly simple. DVC doesn't try to replace Git. No, it augments it. It works with Git, acting like a specialized helper that handles all the heavy lifting, the large data sets, the models, while letting Git do what it's amazing at, versioning your code. And this philosophy is what makes it so powerful. You don't have to throw away your tools. DVC just plugs right in. It works with Git. It makes your experiments shareable. It brings those solid software engineering best practices into data science. And maybe best of all, it uses the cloud storage you're probably already paying for, like S3 or Google Cloud. No need for some new complex server. It's all about fitting into your world. All right, so how does it actually work? Pointers, pipelines, and a pinch of magic. Sounds cool, right? But how does DVC handle these giant files without making your Git repo explode? Well, the mechanics are actually super elegant. Let's peek under the hood. This right here is the magic trick. It's so simple. First, you run a command, DVC add, on your big data file. What DVC does is it takes that file and squirrels it away into a special hidden cache, completely outside of your Git tracking. Then, and this is the genius part, it creates a tiny little text file, a pointer file, and that's the only thing you commit to Git, just that tiny pointer. So what's the result? Well, your Git repository stays incredibly small and zippy because it's only tracking code and these little pointer files. DVC's the one doing all the heavy lifting in the background, using these unique MD5 hashes to keep track of every version of your data. It's a perfect division of labor. Okay, but wait, there's more. DVC isn't just about versioning data. That's only half the story. Its other superpower is building and managing your entire ML pipeline. There's a great quote for this. It's like a Makefile for ML. And you do this inside a file called dvc.yaml. It's where you lay out your entire workflow step by step. You define your stages, like pre-processing the data or training the model. For each stage, you tell it what command to run, what files it depends on, and what files it's going to create. You're basically creating a version-controlled recipe for your entire project. Now, this is where it gets really cool. Let's say you tweak your pre-processing script. Instead of rerunning everything from scratch, you just type DVC repro. DVC looks at that recipe you made, and it's smart. It knows only to rerun the parts of your pipeline that were actually affected by your change. This can save you a massive amount of time and money. Seriously, it's a game changer. So, with this power, it's important to see where DVC fits into the whole MLOps world. Okay, next up, DVC in context, the MLOps landscape. So you've probably heard of other tools, right? Like Git-LFS or MLflow. Where does DVC fit in with all of them? This is a really important question. So the first thing people ask is, how is this different from Git-LFS? And it's a great question. Think of it this way. Git-LFS is for simple file storage. It helps you version individual large files.
DVC, on the other hand, is about strategic workflow management. It's not just versioning a file, it's versioning and connecting your entire pipeline. It's a much bigger, more powerful idea.
Okay, what about MLflow? Are they competitors? Absolutely not. In fact, they work together beautifully. The best setup is to use DVC to handle your data versioning and your pipelines, making sure everything is reproducible. Then you use MLflow for what it's great at, logging all your experiment metrics and managing your model registry. They're two great tastes that taste great together. And when you zoom out and look at the whole MLOps landscape, DVC's unique spot really shines through. See, a lot of other tools, like Git-LFS or MLflow or Pachyderm, they require you to set up and maintain a dedicated server. DVC? Nope. It works with any remote storage you've already got. Its primary job is that core data versioning and pipeline automation, which makes it this perfect foundational piece that everything else can be built on top of.
So let's wrap this up. Why is DVC a game changer? What's the real strategic value here? When we put all these pieces together, why does this matter so much for you and your team? Well, it comes down to this. DVC gives you guaranteed reproducibility. You can link your code, your data, and your parameters to a single Git commit forever. It makes working together so much easier. No more emailing zip files or asking, hey, which version of the dataset did you use? It's efficient, it works with the tools you already have, and most importantly, it brings that rock-solid production-level discipline from software engineering right into the world of data science.
And that really leaves us with one final question to think about for your own projects. Is your ML workflow built on a foundation of code, or is it built on a foundation of proof? Because without something like DVC, you're really just hoping you can reproduce things. But with it, you have cryptographic proof, a completely traceable, undeniable record of exactly how your model was created. And that, right there, makes all the difference.